Welcome, everyone, to another exciting edition of It Depends podcast. This time, I have two guests, and they're both my dear friends from Google Cloud. The reason we have Google Cloud as our guest for this edition of It Depends is because as a Gartner analyst, I have been involved in a lot of Magic Quadrants, and I'm seeing more and more Magic Quadrants where Google Cloud has been quietly and swiftly shifting way to the top of the leaders quadrant. One of them being the Magic Quadrant for cloud database management systems. Google, not only for the second year, is the furthest to the right for vision, but it also improved a lot on execution. So, to get into the details as to what is driving the growth in the data analytics and AI space, I've got the two top people who are responsible for driving this innovation, and they are Gerrit Kazmaier. Gerrit, welcome to this episode. And we've got Andi Gutmans, who was on my podcast 2 years ago when his team launched Alloy DB. And so welcome back to the podcast.
Thanks for having us.
Great.
Thanks for having us. Yeah.
Thank you. So let's start with some introductions. So Gerrit, it'd be great if you can tell us some background and what is your role at Google Cloud.
Sounds great. Hey, as you have said, right, my name is Gerrit. I'm the Vice President and General Manager of Data and Analytics. So in a way, I'm Andy's counterpart, doing all of the systems for data processing, data analytics, up from, data warehousing systems like BigQuery, to BI systems such as Looker, to real-time streaming and eventing in between. So, the big machinery on the analytical side, if you will. Driving product and engineering, the GM role as Google has it, and a close partner to Andi, who is doing, if you will, the same thing on the transactional side.
So you cover the two different spectrums. So Gerrit, you cover the analytics side, and Andi, can you please introduce yourself?
Yeah, I'm Andi Gutmans. I'm the Vice President and General Manager for Operational Databases. So I'm Gerrit's counterpart. We work super closely together on delivering a unified, data cloud, and both across operational databases, analytics, and then of course also with our AI counterparts. So basically, I run the operational database services for Google Cloud, and then I also have a second job, which is running the operational databases for the Google businesses themselves. So Spanner and Bigtable fuel search, ads, YouTube, Gmail. And so an exciting part of our job is being able to take a lot of that innovation that was built for Google and externalize that to enterprise customers.
Yeah, it's actually a good point, Andy, right? A lot of the things that we do are also being used by Alphabet and by the other Google companies as internal technology.
Yeah, I used to say that Google has at least 4 different services with 1 billion users every day, but I think the number is now 2 billion. Right?
I think it's six. It's six. I think 6 products with more than 2 billion.
So there's 6 products with 2 billion users daily. Okay, that is phenomenal scale. And so, what is the Google Cloud's North Star? How does that advise you to come up with a product strategy? So, Gerrit, maybe we can start with you.
Yeah, sure. So, Google Cloud's North Star, you're asking a big question. I think Google ultimately approaches the entire space of cloud from this promise of being transformational, which means that the primary objective that informs our strategy is not making commodity services that you could get any place in the same form factor, but really focusing on what is it, right, that lets company change the way how they do things. And then concretely in the data and analytics space, it's really that promise of, having continuous intelligence, right, versus just, stale, passive BI reporting, of heavily leveraging AI models to analyze data and recommend actions by breaking past the barrier of human reasoning, if you will, and getting to true scale through concept of scaled data together with scaled AI models, and bringing that together in application experiences, right? We just talked about it. Look at Google, all of our products. The whole point is that the value that you have in your data is something you can harness through AI models, that you can expose, through applications that people can actually experience, and then acquire, all of that signal again to make your data foundation richer and better. And you kind of get where this is going, right? The more data you have, the better the models you can provide, the better the experiences you can create, the more data you can acquire. And more companies, I would actually dare saying, all companies are want to have that same virtuous cycle of data spinning, where data becomes a main part of how they create value, and it's actually the essence of how they transform, not technology alone, but actually the business they run.
It's amazing. So what you're saying is that you are not building just products that mimic what others are doing, but like addressing transformational use cases that make a massive gain or massive difference in the businesses. I want to come back to that and talk more about use cases. But before I do that, so Andy, over to you. What's, in your opinion, the North Star?
I think very much what Gerrit said, right? We're the transformation cloud. If you think about, I would say, cloud V1, customers were lifting and shifting to the cloud, but they weren't really like transforming their business. Right? So we have, our focus is really how do we help our customers truly innovate and reimagine their businesses? And doing that based on, the 20 plus years of experience and systems that we've built around data and AI. And that's really our strong point, right? Is helping them on this transformative journey. And so, well, of course, we also do a good job in, I would say, the lifting and shift and kind of modernization side, because that's kind of the table stakes for customers to go into the cloud. Really, they choose us because of that transformative capability that we bring to the table. And that's just been very exciting for us, kind of being on that journey with our customers. And bring that differentiation. One thing I like to say is, our focus is really to help customers innovate, not integrate. When you look at kind of, I would say, the cloud V1, customers will lift and shift, and they have to do all the integration themselves. And if you look at the work that I'm doing with Gerrit and we're doing with our AI counterparts, we're building a very unified data cloud. And so customers can really focus on business outcomes as opposed to having to integrate a bunch of different services. And I think that's really the biggest difference is, the time to value and impact is significantly shorter with Google Cloud.
So can we go deeper into some examples of use cases, and what feedback are you getting from customers that has impacted your 2024 investment priorities?
Yeah, so many. So, hard to pick just one, to be honest. The reality is, right, that every company has an intuition that data is valuable, right? That's not news, kind of everyone gets that. But doing it, really doing it at scale is really, really hard, because, basically what Andy has said, right, what companies experience, and we get to use cases in a second, are getting a whole lot of complication from the technology landscape, right? Many tools, many technology islands that are poorly integrated. There is a reason why people say every AI project is a data project in disguise. Because the data lifecycle behind it is so complex. And secondly, it is extremely expensive, right? So when you think about you want to digitize your business, right, fully, right, and fully harness AI, suddenly you take on a whole new set of items in your cost of goods sold, right? You basically, it becomes a big part of your investment. So what Andy just, talked about when he said we want them to innovate and not integrate, it actually means first and foremost that at a business outcome level, all of that complexity and all of that costs that needs to go away, so it becomes viable, like base economically viable. And actually, a lot of the technology innovation that we are doing, and you said it's a technical podcast, like request-based auto-scaling, for instance, have the full elasticity as a form factor on how we build our services, or I'm sure Andy's going to talk more about it. Spanner, like this idea of like a globally, asset, consistent database, which is unheard of, right? And systems like BigQuery with multimodal storage. It's really delivering on the promise of doing things at scale so they become economically viable. And now that brings us to use cases, right? Whether you take airline travel with Alaska, right? And they want to optimize, your trip experience from planning with an AI assistant your trip to actually the check-in experience from curb to gate. When you look at Walmart, they want to optimize the buying journey that you have on Walmart.com and having the ideal digital shelf, for you, and assemble that based on preference, availability, inventory. When you look at companies like Spotify, right, that want to make sure you get the right content. When you go in your car this morning, it looks like we're all working from home today, but usually when I drive to Sunnyvale, it's like in 1 minute, when you get in the car and you pull out your app and you select, what podcast to listen to or what news songs to listen to. It's such a short window. And it's these moments where everything needs to come together, right? Understanding who you are, what the right content is, having a great application experience that is going to be delivered to you. Whether you're in Alaska booking a trip.com, whether you're on Walmart, shopping, for your daily, needs, or if you're on Spotify, just, to get some content consumed. It's the same virtuous cycle that spins in the background, enables all of these use cases. The one thing that I would like to highlight, which is, I want to build a bridge to what you said on the technology side, is doing it in real time. From a business outcome perspective, what uniquely, makes these examples distinct, just have another one, Home Depot, right? Home Depot, great job, want to optimize not only inventory and restocking, but also the shopping experience of Home Depot shoppers, like with an app, right, which helps them to navigate the store, helps them, to pre-order items, shipping, all of that stuff. It's driven from the idea of data-driven, real-time interactions, and that is both technology and business, right? Because you engage with customers in real time. That's business, and that's the moment where you can prevent churn, drive upsell when they call, call center, where you can make a difference in, their experience with you as a company or in the product. And it's where everything needs to come together on the technology side, basically events that are coming in, AI models that are processing these events and creating, recommendations or actions that should happen now, bringing it back into an application experience that lets people then being exposed and interact with that. Like I said, you open the Spotify app, you go to Alaska.com or to Walmart.com. And that's the unique, I think, the distinct, vision that drives us to say we want to enable this for every company out there to make all of their data, available in real time to power their real business processes, whether that's supply chain or customer engagement.
So if I were to take some of these examples, let's say Home Depot or Spotify, so Andy, I want to understand how do these companies use the operational and analytical systems at the same time? Like what does their value chain look like when it comes to using Google's different products for like real-time streaming, analytics, AI? How does it all come together?
Yeah, no, that's a great question. And, let me double click a bit on the real-time side that Gerrit mentioned. Everyone's going to say, hey, we're going to do real-time analytics. We're going to do real-time serving. But the way we've actually built our systems is fundamentally different than anyone else in the market. When we had to build these data systems for Google, we had to deal with some very challenging situations, right? We have very, very scalable applications. We mentioned the 2 billion users, geo-distributed, right? And then also, real time is just part of what Google had to do, right? So, for example, for ad tech and so on and so forth. And so, in order to deal with all these challenges, and then also needing to do that at a reasonable cost, we basically reinvented how we build the infrastructure. At Google, the infrastructure, I think, as you know, is very, very different, right? We've kind of have disaggregated compute and storage, right? Developers here don't actually know what a VM is. For them, it's all hidden and it's very distributed. We have 2 million miles of fiber, right, that we manage, including terrestrial and subsea cables. So we kind of have really strong infrastructure that can enable compute to go to any piece of storage in a very, very short latency, right? So just as a comparison point, probably in a low few hundreds of microseconds from any piece of compute to storage, whereas in any other cloud where you usually are using blob storage to do that, you're probably talking about 90 millisecond latencies or so on. So what that enables us to do is a few things. One is we can, in very low latencies, fetch the right data at the right time, right? Without having to deal with like scaling issues, caching, additional costs that we got to throw on it. So that I would say is one thing that we can do. The second one is we can actually do that in a workload isolated manner. So how does this come together, right? So for example, BigQuery, which Gerrit runs, right, can actually do real-time analytics on data that's in Spanner, one of the operational databases we have, at any scale, could be a petabyte scale, but with full workload isolation, meaning the application has zero impact, it keeps on running, transactions are running, and so on. That's an example of something that you just can't do anywhere else. And so it does start fundamentally with how we built infrastructure differently. So if you take, for example, Gerrit mentioned the Home Depot before. They're using Spanner, they're using Bigtable, they're using BigQuery, right? And so they automatically get these benefits, right? Where they can start very small, they can grow pretty much to any size they need. They could be in a multi-region topology. They can mix analytical and transactional workloads, and they don't have to deal with the cost, complexity, and availability issues you get in other systems where you've got to move data around and, all sorts of complexities, as you know.
So Andy, the disaggregation of compute and store. So let's drill deeper into that. What is the storage layer called, and how does that operate across different compute use
Yeah,
cases?
so we call the compute layer Borg, and we've written some papers on that so people can kind of read up on that. The storage layer is called Colossus. And these are, very elastic, highly available. Colossus is highly durable, from a file system perspective. And think about this almost as a flat namespace. Of course, it's very secure, but it is flat, which means that any piece of compute, any job that runs in compute on board can access any piece of data on Colossus, as I said, in microsecond latencies. And these are very transient. Like if a workload, for example, if BigQuery needs to do a very complex query for customers, they can very easily scale to more Borg jobs and just get this stuff done much faster. And it's not just a performance benefit, it's a real price performance benefit, because if you haven't built the architecture in this way, you end up having to over provision. And who pays for the over provisioning? It's the customer.
And
right?
it's actually, it's such a good point that Andy's making, Sanjeev, because it builds back to what you were asking about initially. So in the model that Andy had described on our compute architecture, and what I mentioned earlier, that ability to scale on a request basis, it allows us to do truly marvelous things. For instance, in BigQuery and in our other systems that are Borg-based, we can basically scale to the precise demand needs of a single query, of a single request, right? So you don't provision the form factor of a virtual machine or multiple of virtual machines. We basically have full fluidity on a sub-CPU level to allocate compute. And that's ultra efficient, right? Hey, you get exactly what you need. And if your query needs less, we take it away. If it needs more, you get more. But here comes the real kicker. You can also mix all these workloads suddenly that compute here. For instance, in BigQuery, you can basically run an ML model embedded into BigQuery, operating on a huge data set without you ever leaving the governance domain the data lifecycle of the integrated storage system, how Andi had described it. And because it's integrated, the data can reside in Spanner, can reside primarily in BigQuery, or another location, right? It's all completely seamless. And I think that's one of the key things that you want to get right. You don't want selective access from your AI models to your data. So very important. We talk about a company's AI models. We talk about a company's data. Generative AI, wonderful example, right? Because generative AI models, they're super smart, right? They're like a PhD showing up, for the first day to work. They don't know much about the proprietary data, and that's by design, right? Because they haven't been trained on them. They can reason about it, but it's not inherently something which they have been trained or have learned behaviors on. So you want now that, your, model deployment closely intersects with your data platform for all the context, for all of the information that only you have to build something with that model that uniquely differentiates you. And that really only works if you have that seamless integration between your AI plane and the data plane, so you can bring these pieces together without being limited to a small context window or to a small web API that you can invoke remotely, because it doesn't allow you to really tap into the wealth of your data that you already have. So this is how it all comes together in that virtuous cycle of data I spoke earlier about.
So even with generative AI enhancements, whether inside BigQuery or standalone or Vertex, so it is still using the same underlying infrastructure of Colossus for storage and Borg for compute. Is that right?
Yeah, I mean, pretty much. I mean, compute, of course, depends on, you're running these models on GPUs and TPUs, so it's not Borg. But I would say, if you think about the training side, right, the fact that Colossus is so scalable and has pretty much arbitrary throughput and latency means we can hydrate GPUs and TPUs faster as part of training, that ultimately results in lower costs for customers.
Yeah.
Right. So it's just a lot more cost effective to train models on our infrastructure.
Right.
And then, as Gerrit mentioned, when you're looking at the inferencing side, it just allows us to, better connect our data systems and our AI systems like Vertex AI, and really make sure that we're bringing data and AI together. Again, that increases simplicity and decreases cost.
And also, Andi, just to take this a bit further, Borg is what led to the creation of Kubernetes, correct?
Yeah, I mean, I don't know the full history, but it definitely inspired Kubernetes. And of course, kind of Kubernetes is also more of a container-based system.
Yeah.
But Borg has its own nuances on, how granular it is, and it's very much tailored to how we build software within Google.
Got it. So, Gerrit, I'm curious, what were some of the biggest advancements or learnings for Google Data Cloud in 2024? And then we'll move on to 2025. But let's talk about 2024 and your thoughts.
Well, the big two letters, AI, AI.
Yeah, that's true. Yep.
Yeah, because people, I think, there's a tendency to underestimate on how profound the shift is and what it requires on the data system side to provide at multiple levels. For instance, the world's largest data type out there is unstructured data, and it's the least commonly used in enterprises because prior to GenAI, it was very difficult to work with. People have tried, and you can get it to work in isolated use cases, but it requires high expertise, high effort. With generative AI, the capabilities that we get to extract insights, entities, summarize, are so good and so generic. They're almost like a SQL operator, right? The big promise of SQL, make unstructured data flexible and easy to analyze. We get the same with GenAI models for unstructured data. So for us, a big shift was making sure customers can easily tap into unstructured data as a data source in connection with all of the other data. And we spoke about that shared storage backbone. that has been a massive accelerant for our customers out there, because they have the use cases, right? They run their churn models, they run all of that today, and now they can add more data signal to that with data which they have. So basically, we invested a lot in allowing customers to do this with incredible ease, incredible simplicity. Second piece is adding new APIs, vector search, context retrieval, powerful RAG APIs, everything that you want from a data system to give to you so you can build differentiated applications. And then last but not least, the most value-adding point is new data agents. So basically applying the principle of Gen AI to really reconnect with the real problems that people out there have when they're working with data, right? Not the trivial problems like I tell you in natural language what information to look up, assuming that, right, the information exists and someone just, you match the intent, to the entity, but really building models and model architectures that do complex reasoning. You ask an inherently difficult question like, will I make my forecast? What's inventory going to look like next week? Where do I need to pay attention to on my financial metrics? And then have a multi-agent system which is doing complex reasoning to find the right information, curate it, decide on what the best, most concise, most precise answer is, and giving it back to you in an easy way, which could be like a Google Chat message. It could be a dashboard, right? If you would like that modality, it could be a Google slide. That has been by far the biggest investment that we have done, and I think the biggest shift, because last sentence, clearly, Sanjeev, I'm very passionate about this. Data, basically has two levels, right? The amount of data you have, that's value level number one. Value level number two is how broadly can you expose it, to people and processes. And Gen AI basically increases both dramatically. All the unstructured data, you tell me how much there is, probably 90% of data out there is unstructured.
Yeah, unstructured, correct.
So that level gets, lifted. And on the consumption side, suddenly you don't need to be a data specialist anymore. You can ask meaningful questions and get real answers, through Gen AI models. So more people get access. And as a consequence, the entire space of data analytics and AI gets lifted in its economic value.
One of the things you mentioned, I think, was multiple engines. Can you give examples of what engines are you talking about?
Yeah, of course. First of all, we need to understand that when we think of models and model reasoning and tools, we are talking about, look at the latest version of Gemini, right? These are not, single request, single prompt, single response models anymore. You need to provide them tools. You need to tell them how to use these tools. You need to actually train the model in how to use these tools so they become proficient in them. You need to decide how you design APIs in a way that a model can use them effectively. You need to think about different engines for different purposes. For instance, context matters a lot. If you look into a large BigQuery deployment, a large analytical system, hundreds of thousands, 1 million tables, easily, petabytes of data. Well, what do you provide the model with, to reason about? That is a search, a ranking, a retrieval challenge in itself. So, we need to have that integrated data knowledge graph. What Andi and I are building together is an active knowledge graph of data, which basically constant updates with transactions that, coming from Andi to me, or if you will, or coming from Andi into our system rather, updating the knowledge graph, basically a retrieval engine on the analytical side, which ranks them and decides based on Sanjeev, coming online, what does he need? Retrieving the right context with all of those signals, providing that to an analysis agent who calls BigQuery to retrieve data, which calls Vertex AI to train an AI model on an ensemble method, right? And decide what model gives, the best, most accurate answer. handing that over to a summarizing model, which decides should it be Google slide generated, verbal response, or dashboard chart generated, and giving that back to you. So this is the system complexity that I'm talking about, and just to connect it back. What Andi has said earlier, right, it really lives off that intersection of frontier AI models, that unified data stack that combines transaction and analytics with a very rich metadata and data knowledge graph across it.
Oh, very nice. And Andy, how about what are your big achievements in 2024?
Yeah, I think it's very consistent with what Gerrit said. I think what we're thinking about is really two things. One is how do we help developers and organizations build intelligent AI agents and applications, and what does that mean for data? And then the second one is how do we use AI to actually help them be more productive in doing so? So I'd say on the first side, it's very much what Gerrit said, right? We believe that in order to truly activate these AI models, right, you need the enterprise data. So how do you need to evolve the data stack, right? So Gerrit mentioned vector search. There's also full text search. Graph becomes more important. Supporting all the ecosystem frameworks like Vertex and LangChain and Llama Index. And so, a lot of our focus was both on kind of innovating on these capabilities across all of the databases, right? So we've done it in AlloyDB, we did it in Spanner, we even have vector search in MySQL that we built on Cloud SQL. And doing that and then making sure the whole ecosystem is there. The modalities are very, very important also, right? Graph becomes much more important as you're looking at, getting more context from the interconnection of data. So, just a lot of work, I would say, around modalities and around, kind of vector processing capabilities, natural language interfaces to your data. On the how do we use AI to make our customers more productive, I'd say just across the board, everything from AI-assisted database management to AI-assisted database modernization, going from legacy databases to open source databases, helping developers write SQL, through natural language and optimizing SQL. So it's just been very exciting, both, to enable developers to kind of unlock the potential, but then also us being ourselves a user to make our customers' experiences so much better.
We are living in some super interesting times. I mean, that's even an understatement. And not just in AI. I mean, we know AI is transforming literally on daily basis, but even things like data, we are recording this in the first week of February 2025. Just this week, I've seen Snowflake made their Snow Convert free. And then yesterday, Databricks bought a company to help with migrating data from what they call legacy data warehouses, which includes Snowflake, Teradata, Oracle, into Databricks. So, what is your thoughts? So, Gerrit, maybe you have some thoughts on why are we seeing so much of this competitive pressure and companies making their data migrations free or automating a lot of these processes, and how is BigQuery reacting to these new developments as of this week?
Thank you for asking the question, Sanjeev. Because at Google, I think we like to get things done and we don't talk about them, all the time. As a matter of fact, we have migration services, for free available since I don't know how many years. And I think 2 years ago, Andi and I started to make them, large language model based or, generative AI based. So we have like a rule translator, and then we have like, give or take, right, get to 85% translation accuracy, and then we give the really gnarly stuff, a specialized set of LLM operators to translate the rest. And we have Andi has a service formed around that for transactional systems. I have a service on the same tech formed for BigQuery. So we do this very successfully since a long time. And we're always happy when other people see what works and catch up to the best practice. So There is nothing for us to react to because I think we have been leading in that space since a really, really long time, helping our customers with it. And the other point that you asked for, what both I think Andi and I are saying is a dramatic acceleration of data workloads, towards our products, Spanner, LODB, BigQuery, Databrog, and so forth. And the reason being is that you really need to embrace the fact that, for real differentiation in AI, you need to have it connected to your IP, which is your data, right? Your data is your proprietary IP asset to make AI uniquely valuable for you. And the big challenge is, earlier at the very beginning of our conversation, I quoted that old saying, every AI project is a data project in disguise, stems from the fact that legacy system, and I would argue some of you, what you have mentioned, fall in the same category, make working with AI really, really hard. They make it so hard that you can't get it to scale. And what we are offering on GCP is basically that once you are connected into Google's data cloud, right, in our connected systems, from Spanner to BigQuery, that AI is seamlessly integrated with that. And that understanding, right, that in order to get to superior value with AI, in order to compete on the merits of AI, be it the efficiency of the company through automation, be it new products and services that are data and AI assisted or even fully created, you need to have that data foundation that supports that. That's a critical precondition. And I like to believe at Google, there is no place like us that helps companies succeeding with that, hence the transformation cloud.
Yeah, by the way, one thing I would also add to that, Sanjeev, if I can, is, I also don't want to understate the benefit of us actually having DeepMind and having like the AI research in-house, right? So when we want to improve things like natural language to SQL or, modernization assistance and so on, right? We can work very closely with our, model training teams. We can, make sure that we also provide feedback and we get the feedback loop into new models relatively quickly. So our ability to truly iterate, not just on integrating AI, but actually influencing the models that come out of this, that then factor back into our service, I think is a very strong differentiation for us, and allows us to move much, much faster than folks who are sourcing their models from third parties.
Strong.
Yeah. I'm curious, how do you see the IT space transform in a few years? With LLMs, we are making it so much easier, natural language interfaces. So, what happens to people who are learning computer languages, and how's that going to transform, and how the job's going to change?
I think in the big picture, data is just becoming way more pervasive, right? Today, it's not like we are capped by the opportunity with data. The constraints that companies are living in is making the economics work at scale. Hence they come to Google because of the technical benefits that we have stated and the extreme efficiency that we have. As they digitize their businesses, everything becoming more software based. AI will play a key part in that, and they will need the data systems for it. What needs to change and what will be changing is that the data stack itself evolves, right? When you look at, SQL, for instance, we developed a new SQL trait called pipe SQL, which is a different way of you organize SQL, which basically allows you to build way more streamlined data pipelines with that heavy emphasis of data and AI jobs. Secondly, APIs are changing, right? SQL, I think it's a bit ironic, but we said SQL is so great because humans write it so well, right? But if you look at somewhat more sophisticated SQL, it becomes pretty tricky.
Yep.
Very soon, actually, beyond
pages and pages. Yeah.
Exactly, pages and pages. And so for us, we are investing heavily in Python APIs, and not in Python APIs that you can run a Python script over SQL on BigQuery, but Python that basically executes on a request-based auto-scaling right in the core of the data system itself, as scalable, as dynamic as SQL does, but with a Python data frame API over it. And the reason why we do that is because actually we think it unlocks more use cases. It's going to be a dramatically improved API for large language models to operate on. And what Andi said earlier, right, with LODB and BigQuery supporting vector indexing, right, also really changing the mechanics and the APIs within the data system so you can develop new types of applications with it. You will be at Next, I hope, Sanjeev, promise me.
Yep.
Promise us, rather. You will hear some pretty amazing announcements of, what's going to be possible post Next in terms of new ways of working with data.
So I want to dig deeper. I know you cannot tell me what's coming in next on this podcast.
Nice try.
Yes. So Andy, any thoughts on the question I asked about how the space will change? And then I will stick to you and at least tell us what's happening in 2025. What do you expect even at next? So
Yeah, I mean, maybe I'll just share the developer point of view, right? I think it's just so much more fun to be a developer now than it was when I was coding. Like I remember how much time I had to spend on like boilerplate code and so on, right? Like, how much time were we actually focused on like the high value algorithms versus the boilerplate? And I think when I look at our engineers today, they're getting that benefit of having an AI assistant, helping them with, code completion and creating that boilerplate. And so they can really focus more of their time on the bigger picture and the innovation side. Of course, they have to be extremely skilled practitioners, but I think it does, give them more time, for the really, highest impact work. And we see this also in things like bug tracking systems and so on, where you have AI summarization. In some bugs, you could have like a thread of 50 people going back and forth, and it'll take you an hour to read that thing, and we just have like a little AI summarization on top. So I would think that there's a lot of, I would say, wasted time that's being eliminated that really supercharges now what a knowledge worker and developer can do. And so I think that's super exciting. And all of our customers, that's what they're trying to do in their world, right?
What percentage of code completion is now being done using AI? Do you have any
Yeah,
numbers?
I believe the number Sundar shared was 25% of code at Google
25%.
being
That's right.
generated by AI. But of
Right.
course, we all know not all code is equal, right?
Yep.
So I'm sure in the
Right.
25%, there's more boilerplate than there is algorithm.
Yeah.
But that's okay. That's actually the point, right? It's like take
Yes.
away that undifferentiated work
Yeah.
and let developers focus on
Yeah.
where they can add the most amount of value.
Right. So, Andy, without spilling the beans, what are you most excited about for Google Cloud Next, which is coming up very quickly in April 2025?
So I think just from what we talked about last year, right, which is like vector processing, ecosystem integration with Vertex, and so on. We're of course just continuing to innovate, and you're going to see a drumbeat of innovations and improvements, across what we've already talked about. I think the whole world of AI assistants and AI assisted experiences, whether it's in management or
Yeah.
modernization or so on, you're gonna continue to see us investing in that. And I also talk about modalities, right? As we think about graph and full text search and other modalities,
Yeah.
also you're going to continue to see us innovating in that space. So without spilling the beans too much, I would say there's a lot to look forward to, a
Yeah.
lot of innovation happening, and we're super excited to see you at Next and anyone
Yes.
else who's listening.
That's amazing. Yes, people do sign up. In fact, I have to say the uh, Google Cloud Next 2024 happened just 9 months after the previous episode. And in spite of that, the amount of new announcements were mind-boggling. There were so many. And then we came back to our home offices, our workplaces, and then the announcements continued. It just never ends. So I have to. So Gerrit, how about you? What are you most excited about?
Yeah, and I'm going to amend it a bit. Not about next, but next year. About that. So you let me off the hook with not spilling the beans on next. Okay. So I'm really excited about inference time reasoning. And the
Hmm.
reduction in inference costs. You saw today maybe Google's announcements about Gemini Light and super efficient models that actually allows us to build new architectures with these models, complex, many invocations, um, really, really solid tool usage at inference time and improved reasoning steps. And I think ultimately, Sanjeev, what that builds up to, which I'm really excited about, is agent to agent collaboration. Today you see most agentic scenarios are workflow level or domain specific on tasks, but actually you have all of these agents, right, that have own specialization, whether it's through training, through context, through tool usage. And I think we're just one step away from having them collaborate with each other. Look at the innovation Google's leading with agent space.
Mm-hmm.
If you think about a data space, right, think about an analysis agent requiring access to data going to a data engineering agent who's constructing a pipeline, which is going to a data governance agent requesting access, going to an app integration agent, building an integration to an ISV application like Salesforce or something else to acquire data, and having all of that orchestrated, right, through the agents collaborating with each other in long-running cycles, not just this, request response interaction mode, but actually having them complete deep work for longer periods of time with a dramatic increase of reasoning across them. And I think once we go through that area, I think the value this is going to return, to customers first and foremost, to companies is going to be tremendous, much more than what today we are already able to get from it.
Yeah, I really love what all the things you said. So basically, the inference at compute time, reasoning, and so that'll help with agentic, and the fact that we don't really have a common networking protocol to communicate between agents, like a
Yeah.
TCP/IP. So I'm getting a hint that may be coming, and that'd be massive, by the way, because it's not just agents built on Google Cloud. It could be agents built on any cloud platform. So that's a missing piece. So that'd be amazing if we have a common protocol.
Something we all can be excited for, for
Yes.
2025. Yeah.
Yeah. So, Garrett, also, we haven't talked about some other very major topics. So, I want to pick both of your brains on what is the role of open table formats like Apache Iceberg? How's that transforming? And how's data governance compliance also coming into the play?
Yeah, quickly, open formats are really good for the ecosystem, because I talked about these technology islands beforehand, right? Which means that you kind of take the app and the data and, you interlock them tightly with each other. That really stifles how you can collaborate with an open ecosystem of workloads and engines. And I think Iceberg really, there are other formats like, there is Hudi, there is, Delta
Yeah.
Foundation. But Iceberg, I think, really came through to deliver on that promise of being a really solid interop format that also the community organizes around, right? And you see Snowflake, for instance, I just mentioned a few vendors that you highlighted earlier supporting it. We are supporting it. Um, Other cloud providers are supporting it. And we're all partnering on advancing that format as a common standard. And I think the merits are for customers that they really can select the engines that are best for workload without worrying about basically giving away the data, over the data authority. Now, having said that, there are many things that are relevant around open formats. You went there, but security governance and managing that. But there are also other concerns that are equally important, right? You want to have high-performant APIs like streaming ingestion, You want to have high performance workloads running over that high cost efficiency. So actually, if you will, it's kind of a constant race to be better in working with these formats. And I actually think it's really good for the industry at large because it requires everyone to be better. More performance, more feature differentiation, more value add over that shared data format. But having said that, I also want to say there is always going to be a place for managed formats because workloads are different.
Yeah.
SLO, SLI requirements are different. It's, cookie cutter never works, right? That, one size fits all.
Correct.
And for instance, what we see in our customer base is that they really select what makes sense for them on a per use case basis. And the good thing about what Andi mentioned at the beginning, because it's on a shared storage infrastructure, there is actually no technology island. Basically, they configure. I want to use this for that workload in that format because it gives me unique advantages, performance being one, higher compression being another. Or, I configure, this, data set to be available in that format because it gives me interop with different workload engines. So actually, we see both ends.
That's great. Andy, how about your thoughts?
I think Iceberg, I won't talk any more than Gerrit has because I think that's really in his space and, fully agree with what he said. I think just from a data governance perspective, you need to be able to activate all of your data, right, for AI, whether this is in operational stores or analytical stores. And I think this is where really our differentiation and kind of building this unified cloud comes across. So, for example, we're working very closely with Gerrit's team that is, working on Dataplex, unified catalog to make sure that all the operational databases just show up automatically there, right? So customers really are able to get a head start as quickly as possible. Also, where customers may need to move data, whether that is, change data capture into BigQuery or reverse ETL from BigQuery back into the serving side, we're making that experience very, very seamless. So I'd say we're building an ecosystem, right, that is both, I would say, easy and efficient, but also has all the governance and lineage, that customers require. Because ultimately, when they activate the AI with data or, do analytics with data, they will need to make sure that, there's access control and there's clarity, where the data is actually coming from.
I'm curious, are we getting to a stage where every product has so much capability that now they're starting to overlap? For example, AlloyDB has both OLTP and OLAP, right? It has row store, column store. BigQuery is getting real-time ingestion. Both have AI. How's it like? Does that cause confusion? Can a customer say, I'm just going to use AlloyDB or I'm just going to use BigQuery? How's this going to help our customers decide what's the best option?
Actually, what we see is that, you can always start like that, but, customers are using all of these services. So the overlap that you assume, that I think only exists at a level where you're not really looking into a practical solution architecture. Okay. In practice,
Right.
You want to have fantastic transactional throughput, and you want to run operational reports. Obvious, right? And AlloyDB is going to give that to you. And going to talk more about that. But that's a valid need, right? Yet you have terabytes, petabytes, tens of petabytes, hundreds of petabytes of data. You want to train models with. You have complex analysis jobs running in conjunction with. And yes, some of these data pipelines, like in a fraud detection scenario or an online transaction, right? You need to have the real-time event, Lambda-like model, if you will, and you need to combine it with your big data history to make a prediction about is that a good or bad transaction, right? Is this fraud or not, right? So this intersection between real-time stream and analytics, it exists. It exists in practice, based on the very, very real needs that you have when you run this architecture. And that usually is instructive, informative, pragmatic, then that like you use AlloyDB, Spanner, BigQuery, Bigtable together, because in combination they give you that unique capability set that you need to drive your applications and your insights and your ML. And you do this over a shared infrastructure, so you don't have artificial trade-offs by saying, I really would want to use it, but the integration is so complex. Or I would really want to do this, but the data lifecycle is so complex. Because there is no but, this is so at Google, it's seamlessly connected. You really design your data engine model based on your workload needs.
That is good.
I'm sure you have more thoughts.
Yeah, no, I completely concur, and I definitely don't think there's a one size fits all. And I would say that the amount of use cases and usage of data systems is growing faster than the overlap for sure. But if you take that example that you mentioned, I would say the columnar store in columnar engine in AlloyDB is really focused still on the OLTP application, right? But being able to do some real-time reporting and so on and so forth. Actually, BigQuery, as part of federating to AlloyDB, will also benefit from that, right? Because they can scan some of the data faster. But if you if you need to do a very complex analytical query, right? I mean, it's a slam dunk BigQuery. Like that's where you would do it. So I think our customers are definitely kind of figuring these things out by themselves quite easily. Sometimes we have to give them some guidance, but I really think it kind of it actually lifts all boats, because what we're seeing is it's actually increasing usage across the board. And I think it's still pretty clear, like AlloyDB is not trying to be an analytical system. It's really still its foremost focus is transactional, but being able to serve kind of real-time reporting and so on, much more effectively.
That's good. Well, thank you so much for clarifying that. That really helps. And I love the fact that the stack in Google Cloud is so well integrated that it's not such a big decision. You're not making copies of data. You're not moving data unnecessarily. It's all integrated. It's just which system, which product do you end up using. So with that, we are coming to the close of our time. We can still talk about, I had so many questions about data fabric and data mesh, all that, but we'll keep that for next time. I want to end on some thoughts on guidance that you could provide on how should people think about building their career in data space.
Oh, Andi, you have to go first on this one.
Yeah, that's a tough one. I mean, of course, data space is very broad, but I would say that as any knowledge worker, right? I think using these new AI technologies really exposes them not just to the AI technology, but like the underlying data and then the value that the data provides. And I always think like if you start by understanding like the outcome, then it captures your curiosity and where you want to spend time, like understanding the how. And the how, of course, there's a lot of different data systems and things folks can focus on. But I think a combination of understanding the end user, understanding the practitioners, and then of course being curious and diving deep and reading some books or taking some courses on how these data systems are actually built. I was not always a data person. I was actually kind of a language runtime person, and I had to become a data person. And I bought a few books and read and talked to folks who knew a whole lot more than I did, and probably still know a whole lot more than I do. But just the technical curiosity and so on, I was able to learn relatively quickly. And I think we're fortunate at Google that we have so many good engineers around us, right? That if there's anything I need to learn, I have someone I can ask, and they can teach it to me.
Gerrit?
I concur with all the things Andi has said. Data is a deep domain, so it lives on deep technical insights. If you look at the systems that Google built, the leading technology frontier, I think you have to take a real interest in that, right? You have to, forgive me for saying it, you have to fall in love, with data, and really enjoy going deep in the domain, the conferences, the papers. Andy, right? I remember the day the Spanner paper was published. What was it, 2017? Something like that, 2016?
I don't remember exactly, but something like that, yeah.
Like that, I can't recount, but I may not know the year exactly, but I know the day. I know reading it, and I think that is really important because in data, I think you only advance the domain if you really profoundly understand its technology, and like Andy has said, are able to connect that with real problems that enterprises are trying to solve. But like you said, for career advice, I think it really is built on that foundation of deep technology insight. And I like Andy has said, there's a wealth of insights, in Sigma papers, in books, and in videos, in podcasts, Sanjeev, many of you, that you have. And you have organized, right? So I think, go deep would be my advice, go deep.
That's great. So you know what some of my friends have started doing? Sometimes it takes a lot of brain power to read these Sigmod or research papers. So they're actually pointing Notebook LM to the papers, converting it into a podcast where two people are talking and consuming that.
By the way,
So,
I have done that, and it works
oh yeah,
remarkably well. And it's more fun because reading
yeah,
these very long papers is
yeah,
sometimes a bit tough, especially after
yeah,
a long day.
yeah,
And I find that Notebook LM is just like awesome. So
yeah.
Guilty is charged. Yeah, guilty is charged. And what I like the most about this, Sanjeev, is when you actually can go back and say, hey, explain this differently.
Yeah, I,
Give me an example. That is so amazing. I think it's going to do so much good in the education space.
yes, the new version of Notebook LM lets you ask questions as well. So it's phenomenal. So with that, so last question, Gerrit, tell us something fun that you do outside of work, a hobby or something that a
Thank
secret.
you for asking me first before you asked Andy, because now I can take it. Otherwise, he would have taken it. Andy and I are coffee nuts, coffee geeks. Really enjoyed the craft of homemade espresso. That's something I profoundly enjoy.
Oh,
A
wow.
really good cup of espresso, a great cappuccino. Great joy and pleasure in preparing it and
Wow.
in drinking it.
Yeah,
And then and riding my bike, as you can see in the background as well. But I would go with coffee, and it's a shared passion with Andy, as is data.
that is
yeah.
amazing. Espresso and biking.
So Gerrit took my number one, um, but I have to say, Gerrit is extremely good at it.
Oh,
But
likewise. Thank you. Likewise.
I think we talked a bit about the curiosity, and I think Gerrit also said like you've got to be passionate about
Yes.
things. I'm very passionate about the space we're in, and so I think the other thing I like to do, whether it's on my on a drive home or if it's I have a bit of time over the weekend, is actually to watch some YouTube videos or podcasts or so on, just around things that are maybe not, both in my domain, but I would say also adjacent domains, just really kind of making sure like we broaden the aperture, we understand like keeping up to date with what's happening with technology. And I definitely like some of the, I would say, both the market oriented content, but also the much more technically deep content, because I think it's very hard to be in a position that we are and not really understand the details. And so it's fine to kind of keep ourselves up to date on, what's going on and how folks are working.
That's great. This has been amazing. Thank you so much. I know you both are extremely busy and with Google Cloud Next coming up soon. I'll see you both there. Thank you so much for taking the time and coming on this podcast.
Thank you. See you there, Sanjeev. Bye.
Thanks for
Thank
having
you.
us.
Thank you. See you. Bye.